As part of Databricks Certified Associate Developer for Apache Spark 3.0 training, in this sectional module, we'll actually go through the details about reading data into Spark data frames. We'll be reading files into Spark data frames. These are the topics which will be covered as part of this sectional module. First, we'll validate whether datasets are properly set up or not. Then we'll see how to convert JSON to Parquet. We'll also see how to convert comma-separated files to pipe separated files. In this case, both are nothing but text files only. However, we'll be using comma separated files as source and we'll be writing them to pipe separated files. We'll see how to read data files into Spark data frames as a overview. Then we'll actually go through the steps to follow to read data from files into Spark data frame. We will see how to read data from CSV files into Spark data frame. Then we'll understand how to specify schema while reading CSV data into Spark data frame. We'll also use toDF and inferSchema. This comes handy especially with respect to CSV files to actually specify the schema. We'll go through the details about that as part of this lecture. Then we'll also understand how to specify delimiter while dealing with CSV files. Even though the files are termed as CSV, we can leverage other type of delimiters also. We can use not only comma but also pipe or colon or semicolon or special characters such as ASCII null, etc. to specify as the delimiter. We'll also go through something called as options. We should be able to specify options using multiple ways. We'll actually go through the details in this lecture. Then we'll understand how to read JSON files into Spark data frame. We'll also see how to specify schema while reading JSON files into data frame. We will see side effects of inferring schema while creating Spark data frame using JSON files. We'll also see how to read Parquet files into Spark data frame. We'll also go through the details about specifying schema while reading Parquet files into data frame. These are the lectures which you'll be going through as part of this sectional module. Make sure you pay attention and go through each and every lecture. These are very important from both certification perspective as well as projects perspective. As part of this sectional module, we are going to the details related to reading data from the files into Spark data frame. To actually accomplish all the tasks that are covered as part of this sectional module, you need to make sure that you have datasets properly set up. If you follow the course, at the beginning we have a section with respect to getting started with the course. In that we have covered about setting up the datasets. If you have set up the datasets following the instructions at that time, you should be able to validate successfully here and you should be able to move forward with the rest of the lectures in the sectional module. However, if something fails, make sure you go to the initial sections where setting up the datasets are covered. Go to those lectures, set up the datasets, come here, make sure you perform the verification. Once you verify the data is accessible as demonstrated here, then you should be able to move forward and take care of rest of the lectures in this sectional module. If you are using Databricks environment for practice, you should be able to leverage %fs in this manner and you should be able to validate whether the files exist or not in this location. Let's run this. You can see the output here. In case if you are using some other cluster or if you are following the course using ITversity Labs, then this command will not work. This is Databricks specific command. You might have to use hdfs dfs-ls and the output also will be a little bit different. That being said, as of now, if you review the output, we are able to see several subfolders under public retail DB. You can actually go through these. If you want to deep dive onto a specific folder, you should be able to specify the subfolder name as well. Once you specify the subfolder name, you should be able to check the files in that folder as well. In this case, I am running ls on public retail DB orders. You can see the file in that location. Now, let's go ahead and create the data frame by passing this path. Also, we'll be using schema to create the data frame. We'll be using this approach quite extensively and I'll be explaining all the details with respect to how to define the schema and pass the schema while creating the data frame. Don't worry too much about all those nuances at this time. In this case, we are just validating whether we'll be able to use the datasets in this location to create the data frames by reading the files from those locations. I'll be covering the concepts as part of the subsequent lectures in this sectional module. I have created a variable by name schema. It is of type string. I should be able to pass a schema like this to a function called as schema, which is available on top of spark.read. Then we should be able to use CSV to read the files from this location. For the data that is there as part of this location, this schema will be applied. You should be able to preview and see whether it is working as expected or not. You can see that orders is created. You should be able to preview the data. You can also use orders.printSchema or orders.dtypes to actually get the column names along with the data types. You can also use orders.dtypes rather than printSchema. Let me say orders.dtypes. Even this one actually gives us a list of columns along with corresponding data types. That being said, we also have JSON dataset in this location. Let's also validate this location to confirm whether we have JSON datasets as well. We'll be using JSON datasets as well quite extensively. Let's run this. You can see the output here. We have JSON files in this location. This location have folders. The folders have JSON files. you can actually run %fsls on a specific folder as well to review the details. I can say orders here. Now if I run this, you can see there's a file here. This is of type JSON. Now let's validate whether we'll be able to read the data from these files or not using appropriate API. As this file is JSON, I'm using spark.read.json. If at all this file is JSON, we should be able to see the data without any issues. Now the data frame is created. We can actually validate by saying orders.print schema. You can see the schema details here. You can also use orders.show to preview the data. You can see the output here. So we have successfully validated both CSV files as well as JSON files. It is also very important for us to have Parquet files. In the next lecture, we'll actually go to the details about setting up Parquet files. We haven't covered about setting up Parquet datasets at the beginning. Now we'll actually convert JSON files into Parquet using Spark. Make sure you run that notebook even if you do not understand, so that you have Parquet files as well. It is very, very important for us to explore APIs which can read data from Parquet files into the Spark data frames. On top of Parquet files, we'll also have dataset with some other character as delimiter than comma. We'll also go to those details as part of one of the lectures in this sectional module. Then we'll actually go to the details about exploring the APIs to read the data from files into the Spark data frames. Now, with respect to reading data from files into Spark data frames, it will be incomplete if you do not cover Parquet. However, there is no Parquet dataset that is actually set up as part of getting started. Now we can actually generate a Parquet dataset, and we should be able to preserve in Databricks environment or even in HDFS if you are using our own clusters. Then once we have the Parquet datasets, we should be able to explore using those datasets. That being said, let's come up with a logic where we can actually read the data from JSON files and write to Parquet files. It will be a very small piece of code, but it is quite powerful. If you do not understand the overall logic, don't worry too much about it at this time. Just make sure that you run that piece of code in your environment as well. It will make sure that you have Parquet datasets as well. Now let me scroll down here. Let me import something called as getPass. Using getPass, let me get the username. I should be able to say username equal to getPass.getUser. It will actually give us the OS level user that is being used under the hood. In this case, if you are using the Databricks environment, username will be root. Now I would like to use this location /user/root/retail-db Parquet to have the Parquet files. In this case, I would like to use username in place of root. For that purpose, let me say output_dir equal to /user/root. This has to be specified in a single quotes. Also, I would like to use format string. In place of root, I should be able to use username like this. Now output directory will be /user/root/retail-db Parquet. I would like to define additional variable called as input directory. When it comes to the input directory, I would like to use this one. Let me pick this one, public retail-db JSON. It will be a bit straightforward to actually convert JSON to Parquet. It is because we don't need to worry too much about the schema. The schema will be there as part of the JSON data itself. Now let me use single quotes, paste it. Now input directory and output directory are created. We need to read all the files from this location and then write to this location. However, we need to convert the files into Parquet. Now let's come up with the logic. When it comes to Databricks environment, there is something called as dbutils. So using dbutils, you should be able to use something called as fs. It exposes something called as ls. Let me run this. It is a function, and hence I have to specify circular brackets like this. However, I need to specify the path. In this case, the path is supposed to be input directory. So let me say input_dir. Now you can see the details of all the folders in this location. However, there are few files. The files are nothing but create db tables pg.sql. Also, we have something called as load dbtables_pg.sql. I think load is not there. There's only one SQL file, and also there is one unnecessary .git folder. We don't want to process these. So first we need to filter out these things. If you look at the output of dbutils.fs.ls, it is nothing but list of file info objects. You can see the details here. All this output is there as part of the square brackets, which means it is nothing but list of file info objects. Each object is of type file info. You can see here. So if you have file info object like this, then you should be able to use the object name .path to actually get the path of the file. So in this case, I should be able to say for file_path, or let's say for file_path underscore info or file details. Let me say file details in dbutils.fs.ls of input directory. Now if I say print file details, it will be printing using file info because the wrapper function of file info actually returns a string like this. Now I would like to get only the path. Path is enough for us. To get the path, I just have to say file details dot path. Path is one of the attributes in file info object. Now you should be able to get only the paths of each and every folder or file. In this case, I would like to discard this one and this one. If we wanted to discard these two, we can actually come up with a logic like this. We can actually say if file underscore details dot path contains, I have to use dot here. It is of type string. Now I should be able to say contains dot git or file underscore details dot path dot ends with SQL. I would like to discard these two. To make sure they are discarded, we should be able to use not here. Then we can have the condition like this. Now let's actually indent the print into the if. Now let's run this. However, it is complaining saying that string object has no attribute contains. I will not be able to use contains here. I need to make sure I use the appropriate function. One of the ways to solve this problem is instead of using contains, I can actually say dot git in file details dot path. This should work. Now you can see the folders. The .git folder as well as a file with the .sql extension are ignored. Now we should be able to read the data from these files, create data frame off of it, and then use that data frame to write back to Databricks environment or HDFS if you are using non-Databricks clusters. That being said, now what I am supposed to do is I have to create a data frame. Let me say df equal to spark.read.json. Then I have to pass file details.path. So let me use file details.path here. Now for each and every folder, it will actually create the data frame. We are actually looping through all the folders here. That being said, let me improvise on this by saying f. Then let me put this in single quotes, then curly braces. Then I would like to say converting data in file details.path folder from JSON to Parquet. I would like to see the progress as the data is being processed and is being written to Parquet file format. Now, once you create the data frame like this, a data frame exposes attribute called as write. We'll actually go to the details about write as part of next sectional module. For now, don't worry if you don't understand. You can come back to this once again after going through the module which actually covers writing data from data frames into the files. For now, even if you do not understand, just run it and make sure that you have Parquet files as well. In this case, we should be able to say Parquet. Then we should be able to specify the path. First, we need to specify the base location. The base location is nothing but this one, output directory. So let me say f, then in single quotes, in curly braces, output directory. Then we have to give the folder name. The folder name is supposed to be this one. So we have to extract this part from the file details.path and we have to pass that one here. So let me say dataset directory. Now let me come up with a logic to actually extract this part and assign it to a variable called as dataset directory. For that, I should be able to say data underscore set underscore directory equal to file underscore details dot path dot split. In this case, we should be able to use / to split. If you use -1, it will return empty string. If you use -2, it will return the folder here. I'm actually coming from the end. So in this case, I should be able to say -2. Now dataset directory will be this one. So we'll be able to read the data frame, which is nothing but df, into the appropriate folder based upon the folder which we are actually using to process data while converting from JSON to Parquet. However, when it comes to writing data to the target location, it might generate more than one file. I would like to restrict that. I would like to write each dataset in one file only. For that, we should be able to use something called as coalesce on top of df. It will take care of creating only one file because we are passing one to coalesce. Now, before running this, let me comment this out. Let me actually print this part to make sure that the output directories are as per the expectations. I can actually say print, then output directory / dataset directory. Let's run this. You can see here the output directory is as per the expectations, and hence we should be able to delete this. Now we should be able to uncomment these 2 lines. Now we should be able to run it. If there are any bugs, we'll fix those. In this case, it is failing because I have already ran it in the past. That's why it have failed. To make sure that it can overwrite, we should be able to use mode equal to overwrite here. So let me say mode equal to overwrite. Now let me run this. This time it should work. You can see the output here. Already categories is converted, customers is converted, departments is converted, order items is converted, orders is converted. Now products is also converted. Now we should be able to pick this location. In this case, it should be not this location, but this location. We should be able to pick this location. Now we can actually say dbutils.fs.ls, paste here. Now let's run it. You can see that this location contain folders. You can also specify the subfolder name to see the list of files in that folder. Let's validate by saying orders. Let's see if we have Parquet files or not. You can see the extension. The extension says Parquet. Also the files are compressed using Snappy. As part of this location, there is only one file. The reason why we are seeing only one file is because of the coalesce. If you do not have coalesce, you might end up having more than one file. All these additional files are just overhead and they are not actual files. This is the only file which contains the data. Now we can also validate by using spark.read.parquet, because the files in that location are of type Parquet file format. To see if you'll be able to read using appropriate APIs, I'm actually testing using this piece of code. In this case, I just have to copy this, paste in this. Let me actually define a variable by name orders, then equal to. Now let me run this. You can see that data frame is created successfully. Check the data types of each and every field by using D types. Also, you should be able to use orders.show to preview the data. The output is as per the expectations. This is how you can actually set up the Parquet dataset even though you do not have one. Irrespective of the datasets you have, in case if you want to set up datasets using different file formats, you should be able to leverage this cool technique. That being said, don't worry too much if you do not understand the logic which is developed here. Just run and make sure that you have Parquet files also. Going through details related to Parquet files is very, very important. It is becoming the standard with respect to file format in data lakes and also while processing the data using platforms such as Databricks, and hence having Parquet files is very, very important. That's why I have gone to the details with respect to converting JSON files into Parquet, because I do not have the Parquet datasets. As part of this lecture, let's go to the details related to converting comma-separated files to pipe-separated files using Spark. Already we have seen similar logic where we have converted JSON files into Parquet files. This time we are trying to convert comma-separated text files into pipe-separated text files. We are just changing the separator or delimiter from comma to pipe. That being said, we'll be having both the datasets by the end of this. Now, first let's run this. We're actually creating two variables. One of them is nothing but input directory. It is pointing to public retail DB. It contains the CSV files in subfolders for each and every dataset. Also, we are creating output directory. It is based on username, then retail DB pipe. Based upon the user which is used to log in into the environment, it will change. In this case, it will be /user/root/retaildb pipe. Now I'm actually running dbutils.fs.ls on input directory. You can see that it contains 6 folders. They are nothing but categories, customers, departments, order items, orders, products, which means we don't have to have this piece of code. In this case, we do not have the files with the SQL extension, and also we do not have a .git folder, and hence even if we remove this, it should work without any issues. But in case if you forget to delete the .git folder and .sql files, this will make sure that those are filtered out. That being said, you can see the logic here. We are actually going through the output that is written by this. It will actually return list of file infos. You can see here. Once you have file info object, you should be able to access a path by using the object name .path. That is what we are using here. And then we are actually comparing it with SQL and also whether we have Git as part of the path or not. Then we are actually printing saying converting data in file details.path folder from comma separated to pipe separated. As our original dataset is comma separated, we should be able to use spark.read.csv with file details.path. The data in that location will be read into a data frame. The data frame name is nothing but df. After that, we are actually getting the folder name. We are actually extracting this information from each and every path. Then we're actually saying data frame dot coalesce of 1 so that the data is returned to only one file. Then dot write, then dot mode of overwrite. If the target folder already exists, it will just overwrite and it will actually place the new dataset in the form of files. However, this time when the files are being written into this output directory / folder name, which is based on these names, the data will be written using pipe as delimiter. Now we should be able to run this. Now you can see that all the data which is comma separated in source files are now converted to pipe separated and they are written to the target folders. That being said, let's validate whether the data is pipe separated or not. For that, I'm first defining the schema. Now I'm actually using spark.read.schema.csv and trying to read the data from one of the file into a data frame by name orders. However, by default, when we use spark.read.csv, it will try to read using comma as delimiter. However, our data is pipe delimited. In this case, let's see how it actually behaves. When it comes to the schema, it looks good, but when we actually say orders.show, you can see the output here. The output is actually showing all null values because it is trying to interpret the data using comma as delimiter, which is default when we use spark.read.csv. In this case, to make sure that we can read the data which is there as part of pipe delimited files, we have to use additional argument. The argument is nothing but sep. We should be able to specify sep like this. Then we should be able to say equal to, then pipe. Now let's run this. Now the data frame is created. Now let's review the data by saying orders.show. You can see the output. The output is as per the expectations. It means we have successfully generated pipe delimited files in the target location using the comma separated files as reference. As part of this lecture, let's get an overview of reading data files into Spark data frames. When it comes to Spark, if you have Spark session object, then it exposes an attribute called as read. Using read, we should be able to use appropriate functions to read the data from files into the data frame. When it comes to the read, which is there as part of Spark session object, it is of type data frame reader. When we actually use Databricks environment, there will be a Spark object implicitly. You can actually validate by saying Spark here. You can see the details about Spark. You can also get the type of Spark by saying type of Spark. When it comes to type of Spark, it is nothing but pyspark.sql.session.spark session. Any object which is of type Spark session exposes an attribute called as read. This is attribute not function. Read is of type data frame reader. You should be able to run this and you should be able to see the type of read. It is nothing but pyspark.sql.readwriter.dataframeReader. So dataframeReader as a class exposes several APIs. We need to make sure we have better understanding of all those APIs which can come handy to actually read the data from files into the data frames. From the perspective of the sectional module, we should be familiar about how to read files using direct APIs such as CSV, JSON, etc. which are available under spark.read. You can explore all the functions by saying spark.read. And then by hitting tab. When it comes to direct functions, they are nothing but CSV for CSV, JSON for JSON, ORC for ORC, Parquet for Parquet, text for single column text files. You should be able to leverage any of these functions to directly read the data from files into the data frame. Also, from the perspective of the sectional module, you should be familiar about using format and load that are there under spark.read. Once again, if I add this new cell and then say spark.read, then dot, and if I hit tab, you can see that it have format and also it have load. So using a combination of format and load, we should be able to specify the format of the file using which we are supposed to read the data from the files into the data frame, and also the path, load text the path. These are the functions which are available on top of spark.read. We can use format also to actually get the data from any of these standard file formats. Also, when it comes to reading data from files into the data frame, you should be familiar about specifying the options as arguments as well as using functions such as option as well as options. We'll go to those details as part of this sectional module. When it comes to supported file formats, these are the supported file formats out of the box. They are nothing but CSV, text, JSON, Parquet, ORC. You have already seen that there are functions related to these file formats. Also, we can easily plug in libraries with respect to XML and Avro, and we should be able to use Spark-based APIs to process the data which are there using these file formats. Even non-standard ones, if the vendor actually provides a plugin, you should be able to plug in and you should be able to take it further. From the perspective of the certification exam, it is very important for you to have good understanding about CSV, JSON, Parquet. These three are the most commonly used file formats these days. Also, you should understand the relevance of compressed files. When it comes to compressed files, with respect to reading the data, you don't need to break your head. By default, if the files are compressed, as long as we use appropriate API based on the file format that is there as part of those compressed files, it will work seamlessly. But with respect to writing, you need to spend some time to actually understand the relevance of compression. You will understand by the end of this section, as well as by the end of the section where I'll be covering how to write data frame into the files. That being said, these are the important things which you need to keep in mind from the perspective of reading the data in files into the Spark data frames. There will be quite a few questions with respect to reading data from the files into data frames. As long as you have good handle on these few functions, you should be able to answer all those questions with ease. As part of this lecture, let's go to the steps to follow to read data from files into Spark data frame. The reason why I'm covering this is because many professionals tend to use the APIs of their choice without exploring the datasets. Because of that, they'll be running into too many unexpected issues, and it will be a nightmare to troubleshoot those issues. If you follow these steps, it will actually take care of mitigation of running you into the unexpected issues because of not using appropriate APIs to process the data. First of all, we need to check if the files are compressed or not. When it comes to files being compressed, you will see extensions such as GZ, Snappy, BZ2, etc. as part of the file names. Also, you need to make sure you understand the file format. You need to make sure whether the file is of type text or JSON or Avro or Parquet or ORC, etc. If the file format is Avro, then there is no direct API as part of Spark.read. You will not be able to process the data. You should not be using any other APIs to process the data. You need to make sure that Avro is plugged in into your session, and then you have to take it further. If the dataset is of type JSON, then you have to use spark.read.json to read the JSON files into the data frame. So depending upon the file format, you have to use appropriate API. However, sometimes files will not have extensions. If files doesn't have extensions, then you need to make sure you do your diligence to understand the file format. Then only you should take it further. As part of the projects, typically the information will be provided as part of the technical specs. You don't need to break your head to identify the file format. You just have to talk to the source systems which are sending the data, or you have to talk to your lead or architect to determine the file format. Don't break your head, and if you are not able to figure out, don't just experiment with API of your choice. You should have absolute clarity about the file format, then only you should take it further. If there is no information, then there is no other choice. You have to use trial and error, and you have to identify the file format, and then you have to take it further. Also, if the files are of text file format, then you have to take care of additional validations. You need to check what is the delimiter that is being used, whether it is comma or pipe or some other delimiter. Also, you need to check whether the dataset have header or not, which means whether if each and every file have a header or not. If the files have header, we should be able to determine the columns using the header. However, if the files doesn't contain header, then we need to determine the column names. We should be able to get the column name details using control files that will be sent across along with the dataset. When you actually start working on the projects, if your datasets which are in text file format doesn't have header, then the information will be passed to you in the form of a control file or external properties file. You should be able to leverage it, and you can actually take it further. Once we have better understanding of our data, we should be able to use appropriate API under spark.read to read the data. Now let's go to the details about how we can perform these tasks using the datasets which we have. Let's say I want you to read the data in this location into a data frame. First, we need to make sure the location is correct. For that, we should be able to use appropriate command based upon the environment we are actually doing this validation. In this case, I am actually using Databricks environment. As part of the Databricks environment, I should be able to validate the location using file system commands like this as part of the Databricks notebooks. Now let me run this. You can see that it have written a file. It means the location is correct. But when you actually look at the file name, it doesn't have any extension. So we don't know whether it is a text file or CSV file or JSON file or Parquet file. You need to talk to the source systems and understand what is the file format. Many times you might end up having technical specs. You have to go to the technical specs, and as part of the technical spec, you will have the information. Also, sometimes you might have this information as part of the external properties file, which actually drives the runtime behavior of our data processing pipelines. Using those sources, you should be able to determine the file format even if there is no extension. Don't assume a specific file format if there is no extension. In case if you don't have any other source where you get the information related to the file format, then you have to do some trial and error and you should be able to determine the file format. I will leave to you. It is not very important from the certification perspective. From the project's perspective, you will not be encountering these issues. As you will be working as a team, you will be getting the information without too many challenges. Using whatever source you have, you should be able to determine the file format in this location. In this case, these files are nothing but text files. Now we need to understand the delimiters in these text files, and also we need to determine whether the files have header or not. Again, in this case also, text specs or external properties files will come handy. Based upon the information that is there in those sources, you should be able to determine whether the files have header or not, what is the delimiter that is being used, what are the data types of the column names, so on and so forth. That being said, once you have the files, once you determine their text files, you should be able to use text to actually understand the details related to header, delimiter, etc. Text is one of the APIs that is there as part of Spark.read. Using that, we should be able to read the data and we should be able to validate. So in this case, I can actually say spark.read.text. Now I should be able to pass the path here. Now let me say show. When you use the text, it will actually read the text data as single column data. You can see here, there is only one column by name value. If you review the data, you should be able to get the details whether the files have header or not. In this case, you can see that there is no header. You can also use truncate equal to false so that we get complete line information here. You can see value is the column name and you are able to see first 20 lines in the file. You can see data is comma delimited or comma separated. Also, you can confirm that data doesn't have any header. This is how you should be able to take care of the analysis, and then you can take it further. If you directly have access to the underlying operating system, then you should be able to log in. If the files are available locally, you should be able to open the files using VI editor or nano editor, or even using commands such as tail, cat, head, etc. Using those commands, you should be able to determine the details of these text files. It is very important for you to understand the details related to the header and also details related to the separator. There might be other things also which you need to analyze, but these are the bare minimum things which you need to keep in mind. Once you understand this, then you can actually use the API with appropriate arguments to convert the data in this location into the data frame. Now, this location have JSON files. Let's see whether we will be able to figure out. Even this one doesn't have extension JSON, so we don't know whether these are JSON files or not. Again, you can go to your sources and confirm the file format. Once you get the details that the file is of type JSON, then you don't need to worry too much about column names or data types, because data itself will have the column names as well as the data types, and hence you can directly use appropriate API and take care of reading the data from the file into the data frame. In this case, you can actually copy, then add a new cell, then you should be able to say spark.read.json, pass the path. As long as you know this location have JSON files, you should be able to use this directly. You don't need to spend additional time to understand the delimiter and whether the files have header or not. Now you can see the details about the data frame. You can also preview the data by saying show. You can see the output without any issues. When it comes to Parquet files, you typically see extensions. You can see here, as part of this folder, there is only one Parquet file. Let me scroll down here. The Parquet file is nothing but this one. You can see there is an extension. Even if it doesn't have extension, you should be able to determine the details by going to the text spec or by going to the external properties file, where the file formats will be specified at global level or at each table level. That being said, in this case, using the file name itself, we can figure out that the files are of type Parquet, and hence we should be able to use spark.read.parquet, pass this location to actually read the data in this file into the data frame. Also, if you look at the file name, it has Snappy in it. Snappy is nothing but a compression algorithm that is being used whenever we write data into the Parquet file format. We typically compress the data. The default compression algorithm for Parquet files is nothing but Snappy. That's why you are seeing Snappy here. The actual file format is nothing but Parquet. That being said, this is how you should be able to go through the details with respect to the files and then use appropriate API to read the data from files into the data frame. As part of this lecture, let's go to the details related to reading data from CSV files into Spark data frame. We should be able to leverage multiple approaches to do so. The first approach is by using spark.read.csv. We should be able to pass the path to the folder which contains CSV files as a string to spark.read.csv. It will actually convert data in the files into the data frame. Also, we should be able to leverage spark.read.format with CSV like this. It exposes a function called as load. Using load, we should be able to specify the path to folder as a string. Then the files which are there in that location will be converted to data frame. We can explicitly specify the schema as a string or using structure type. We will be seeing details as part of subsequent lectures in this section. We can also specify different delimiters while reading the data from CSV files into the data frame. We will also see examples related to that as part of subsequent lectures in this section. If the files have header, we can create the data frame with the schema by using options such as header and inferSchema. It will pick column names from the header while data types will be inferred based on the data. We'll also see an example with respect to that as part of subsequent lectures in this section. In case if the files does not have header, we can still create the data frame with schema by passing column names using toDF. Also, we should be able to infer the schema to get the data types of the columns using inferSchema option. We will also see an example with respect to creating data frame with a schema using toDF and inferSchema as part of the subsequent lectures in this section. Now let's go to the details with respect to default behavior when we try to create the data frame without passing any other options than the path of the folder which contain the CSV files. It will actually delimit the data using comma as separator. As long as the files have comma as delimiter, it will work without any issues. When it comes to the names of the columns, they will be system generated. Also, all the fields will be of type strings. When I say inferSchema, the schema should be defined based upon the data. By default, the schema will not be inferred when we use spark.read.csv to read the CSV files into data frame. Now, let's run this. A data frame by name orders is created. You can actually go to the details about the columns. You can see the names of the columns. They are nothing but underscore C0, underscore C1, underscore C2, underscore C3. They are all system generated names. You can also run this to review the names as well as data types. You can see that all the columns are of type string. So these are the things which you need to keep in mind. In our case, the files in this location are comma separated. The data have 4 fields. That's why we are seeing 4 fields here. So this is the default behavior with respect to spark.read.csv. Now let's go through the rest of the details where we should be able to create data frame based upon the characteristics of the data by using appropriate options. As part of this lecture, let's go to the details related to specifying schema while reading CSV data or files into data frame. There are multiple ways to do so. One of them is nothing but using a schema function that is available on top of data frame reader. Already we have explored that spark.read is of type data frame reader. It exposes several functions such as CSV, JSON, text, etc. It also exposes a function called as schema. We should be able to specify the schema using schema. It again returns a data frame reader, which means all those functions that are available on top of spark.read will also be available on top of the object which is returned after invoking schema. Let's look at the help on spark.read.schema. You can see that it takes one argument. The name of the argument is nothing but schema. When you actually go to the details with respect to schema here, it can be of type structure type object or it can be string object as well. When it comes to string object, you should be able to pass the schema in this manner. You just have to specify the column names along with the data types. Each column name and the data type should be separated with comma. Also, we should be able to build a structure type object and we should be able to pass structure type object to define the schema. You can also look at the help on spark.read.csv. As part of CSV, we have schema keyword argument. You can see here. Even this one is same as what we are seeing here. You should be able to scroll down and you should be able to review the details with respect to schema as part of the parameters. If you go to the details, it is same as what we have seen earlier. Even spark.read.format, then load. Let me actually say spark.read.format. Let me pass CSV to it. Then let me say dot load. Let me run. You can see that it also takes a keyword argument by name schema. Even you should be able to pass the schema to load function. These are the different approaches where you should be able to leverage to define the schema while creating the data frame from CSV files. Now, when it comes to schema, it can be a string object like this. This is a valid schema in the form of string. Let's run this to create a variable called as schema. Now we should be able to pass schema to function called as schema that is available on top of spark.read. Then we should be able to invoke CSV in this manner. It will take care of applying this schema while creating the data frame. So this highlighted piece of code will actually create a new data frame with schema. We should be able to preview the data by using show like this on top of that data frame. You can see the column names here. They are from the schema. You can actually go to the results. The results are as per our expectations. You can also use print schema or dtypes on top of this to actually validate the data types of each and every column. So let me add another cell here. Let me say dot dtypes. Let me run it. You can see the column names along with the corresponding data types. In this case, order ID and order customer ID are of type int, whereas the order date and order status are of type timestamp and string respectively. The reason why we are seeing those data types is because it is how the schema is defined and then passed to schema function while creating the data frame. Now we should be able to pass the schema in this manner as well. This time I am directly using spark.read.csv without schema in between. However, we should be able to pass schema as keyword argument in this manner. You should be able to preview the data. You can see that the output is as per the expectations. Again, this is what will actually return the data frame. On top of data frame, we are using show to actually preview the data. Now, when it comes to specifying the schema, we should be able to use pyspark.sql.types. It exposes several types. You can see here, I have struct type, struct field, integer type, timestamp type, string type that are imported from pyspark.sql.types. Struct type is the main thing which we need to consider to build the schema. A struct type is nothing but a list of fields. You can actually import all this. Then you should be able to get the help on struct field because we have to build a list of fields to build a struct type. That's why I'm actually checking the help on struct field. If you look at help on struct field, you can see that it have a constructor. This is the constructor of struct field class. It takes column name, data type, whether column is nullable or not, and also additional metadata related to the column. Don't worry too much about these two for now. Just focus on name and data type. When it comes to data type, you should be able to pass the constructors of these classes. We have classes for all primitive types as well as advanced types such as array, struct, map, etc. That being said, now you should be able to see the logic to actually build the list of struct fields. You can see here all these fields are enclosed in square brackets, which means it is nothing but a list. If you look at each and every struct field, you have the column name along with the constructor of corresponding data type. As order ID is of type int, we are actually specifying integer type as data type for this field. In the same manner, we have order date along with its data type, order customer ID along with its data type, order status along with its data type. This is nothing but a list. You should be able to pass the list to struct type. It will take care of creating an object of type struct type. Once we run this, schema will be of type struct type. Once we have struct type object, we should be able to pass it to schema like this, or we should be able to pass to CSV using keyword argument schema in this manner. Let's run this to create struct type schema object. Now struct type schema object is created. You should be able to validate by saying type of schema. You can see the type of it. It is nothing but pyspark.sql.types.struct type. Now we should be able to run this. You can actually preview the data. Show is used on top of the data frame, which is actually built using the schema, which is being built using struct type. We can also pass the schema in this manner. You can actually review the output. If you would like to explore more details about classes such as integer type, timestamp type, string type, etc., you should be able to use help. All these are nothing but classes. You can actually review the details here. They are not very complicated. They are pretty straightforward. We also have functions such as from internal, JSON, JSON value, etc. You don't need to worry too much about those things at this time. Now let's review the help on struct field once again. Let me say help. Then let me add struct field to it. If you look at the constructor related to struct field, it actually accepts 4 arguments: name, data type, nullable, then metadata. Don't worry too much about metadata. However, even if you specify nullable equal to false, it might not strictly enforce on top of data frames. Let's look through the details so that you understand what I'm talking about here. Let me scroll down. Now let me create an object by name schema. In this case, you can see that each and every field is created with a nullable equal to false. Now schema object is created using struct type. This logic will take care of creating the data frame using this schema where nullable is false with respect to each and every field. When we actually use show on top of the data frame, you will not see any difference. It will be the same because we have 4 columns as part of the data and you should be able to see the data with respect to those 4 columns. Also the data types match and hence it works without any issues. However, if you actually use print schema to preview the schema, you can see that nullable is still true. So I'm not 100% sure about what is the usage of nullable equal to false. The only thing I can say is it might not be strictly enforced. That being said, as we have seen earlier, we should be able to pass the schema as keyword argument as well. Even this one will work without any issues. So this is how you should be able to specify schema while reading CSV data into data frame. It is very, very important for you to understand all different options we have. Also, it is very, very important for you to understand we should be able to pass the schema as string or as struct type object. When it comes to struct type object, it is nothing but list of struct fields. As part of struct field, we typically have call name, data type, and also additional information such as nullable as well as metadata. However, nullable and metadata are not very important. You should at least build the struct field with the call name and data type. As long as you have a list of struct fields, you should be able to use that list to build the struct type object. Once you have struct type object or string with correct schema information, you should be able to leverage that as a schema while creating the data frame from data in the CSV files. As part of this lecture, let's go to the details related to using toDF and inferSchema while creating data frame from CSV files. Using toDF function and inferSchema keyword argument or option will facilitate us to create data frame with schema. When we say schema, we are talking about call names along with data types when we actually have the data frame. That being said, first let me create a variable by name columns. It is of type list. This list contains call names. You can see the call names here. They are nothing but order ID, order date, order customer ID, order status. Let me run this. Now let me say type, then pass columns to it. You can see that it is of type list. Each element in this list is of type string. Now we should be able to say spark.read.option of inferSchema comma true. It will actually facilitate us to get the data types of each and every field that is there as part of the CSV files. Let's make sure we copy this. Let's paste here. Now let's say dtypes. Let's run this. This will actually return the data frame. Dtypes will actually give the call names along with the data types of this data frame. You can see the call names here. The column names are system generated because we haven't specified any call names while creating this data frame. However, as we have said inferSchema as true, you can see the data types here. When it comes to order ID or the first column, it is of type integer. When it comes to second column, it is of type string. When it comes to third column, it is again of type integer. When it comes to fourth column, it is of type string. Now to make sure that we have appropriate column names, we should be able to use toDF function. Using toDF, either we can actually specify the call names comma separated, or we should be able to convert this list to varying arguments and we should be able to pass it to toDF. Let's go to the details so that you understand what I'm talking about here. We can actually copy this, paste here, then we should be able to say toDF. As part of toDF, we should be able to pass these as arguments. In this case, I'm passing all these four as direct arguments. You can see that it is working as expected. It have created the data frame. You can also preview the data by using show on top of it. Also, if you look at the help on toDF, now let me say help, then let me copy and paste this. Now, if we run it, you can see the syntax with respect to toDF. It takes one argument. The argument can be varying number of columns. You can pass as many column names as you want. However, if the column names are part of a list, we need to convert this to varying arguments. The way we should be able to convert the list to varying arguments is by using star like this. It will take care of converting the list into this format. Then toDF will be invoked. Now you should be able to run it. You should be able to see the data frame details here. You can also use this option. In the previous two cases, we have passed inferSchema with true as part of option. In this case, we are actually passing keyword argument inferSchema with true. It will actually take care of inferring the data types of each and every column. Now let's run this and let's see the details here. You can see that it have created the data frame. The data frame contains 4 fields: order ID, order date, order customer ID, and order status. You can also use show on top of it to preview the data. You can see that the data is as per the expectations. Now you can review the output here. Also, let's look at the help on spark.read.csv. For that, I'm adding a new cell. Then I'm saying help, then spark.read.csv. Once we run, we should be able to go through the usage here. One of the keyword argument is nothing but inferSchema. By default, it is none. If we say true, it will actually get the data types of each and every field by going through the entire data when we use spark.read.csv and pass the location of the files to it. This is how you should be able to use the combination of toDF and inferSchema to get the schema defined when we create the data frame using CSV files. As part of this lecture, let's go to the details related to specifying delimiter while using CSV to create Spark data frame. First, let's create schema. In this case, I'm creating schema as string. Now let me import getPass and then create a variable by name username. The reason why I'm actually doing this is because when it comes to the datasets, we have pipe delimited dataset in this location /user/username, which is nothing but the user which is used to log in into the cluster. Then retail DB pipe. Then orders have the orders dataset where the files are pipe delimited. To make sure we can read the data from that location, we are actually using this logic. This is nothing to do with Spark APIs. Now, if you run this, you can see that it is displaying all nulls because we haven't specified the delimiter. Also, when it comes to the data in this location, the delimiter is pipe. As the delimiter is not specified, it is actually using comma as the delimiter. That's why you are seeing all nulls here. Now, let's look at the help on spark.read.csv and then we should be able to take it further. When you actually say help and then spark.read.csv, then run this, you should be able to see all the keyword arguments that are accepted. One of them is nothing but sep. Using sep, you should be able to specify the delimiter or separator. Then you should be able to take it further. In this case, we have to use sep. We have to pass pipe to it. Once we pass pipe to it, we should be able to read the data from our pipe delimited files without any issues into the data frame. You can see the example here. In this case, I'm saying spark.read.schema. I'm passing the schema in this manner. Then using CSV, I'm specifying the path in which we have the files. Then using keyword argument sep, I'm actually specifying the delimiter or separator. It will actually create a data frame. This time the data frame should be fine. We should be able to preview the data to confirm whether the data frame is created properly or not. You can see the output here. The output is as per the expectations. You can also use count to actually get the count. We should be seeing 68,883 because the original dataset that is part of orders contain those many records. Let me actually use count on top of this in this manner. Count is a function which is available as part of the data frame. Using count, we should be able to get the number of records from the data frame. You can see it have returned 68,883. That being said, we should be able to specify the schema in this manner along with sep. Even this one will give the same result. You can see the details here. In case if you want to get the call names and the data types, you should be able to use D types. It will give us both call names as well as the data types. In this case, the call names as well as the data types are based on the schema which is passed. The schema which is passed is nothing but this one, where order ID is int, order date is timestamp, order customer ID is int, order status is string. You can see the same details here. Even if you do not see the data properly because of any incorrect delimiter or whatever the issue is, still the schema will reflect in this manner only because we have explicitly specified the schema. That being said, this is how you should be able to specify delimiter while using CSV to create Spark data frame from CSV files. As part of this lecture, let's go to the details about using options while reading CSV files into Spark data frame. Even though I'm going to cover using CSV files as an example, whatever we are exploring as part of this lecture is applicable with other file formats as well. When it comes to the options, we should be able to pass the options using different ways. One of the ways is to use keyword arguments as part of APIs. We should be able to use keyword arguments as part of load function as well as direct APIs such as CSV. Also, we should be able to pass options using spark.read.option as well as spark.read.options. When it comes to spark.read.option, we have to use option multiple times depending upon the number of options we want to pass using option. Using options, we should be able to pass all the options at once leveraging the keyword arguments concept. If key in the option is incorrect, then the options will be ignored. It is applicable with respect to both option as well as options. If there are any typos with respect to keys as part of option or options, they will be just be ignored. You will not be seeing any errors or exceptions. Depending upon the API based on the file format, the options as well as arguments vary. When it comes to CSV, you will see options such as separator, header, so on and so forth. When it comes to JSON, Parquet, etc., those are not relevant. Now, that being said, let's make sure we create an object by name username. It is of type string. Let me run this to actually understand the default behavior. You can see that it is actually creating the data frame. However, if I say orders.show, you will see incorrect data. It is because the actual data in this location is pipe delimited. However, we are using spark.read.csv. It will try to delimit the data using comma as delimiter. As comma is not the delimiter as part of the files, you can see that it have created data frame with only one column. It is of type string. You can see the complete records in each and every row as part of this single column itself. Now let's run this and review the help on spark.read.csv. You can see that there are a bunch of keyword arguments. Some of the important keyword arguments are nothing but schema, sep, quote, header, mode. Mode is primarily used to deal with corrupt records. inferSchema, in case if you want to infer the data types based on the data, you should be able to use inferSchema. We have seen this already. Options such as ignore spaces, null values, multiline, etc. When it comes to ignoring spaces and null values, there are multiple keyword arguments. You just have to evaluate the keyword arguments against your requirements and you should be able to take it further. In this case, I would like to specify the schema by using inferSchema, and then using toDF, I would like to pass the call names. You can see here, I'm using inferSchema equal to true. Then I'm actually using toDF to pass the call names. Also, I would like to just use header equal to none. Header is anyway none by default. In this case, it will not have any impact, but I would like to have enough options. That's why I'm using this. Also, we need to specify separator as delimiter because our data in the files are not separated by comma in this location. They are separated by pipe. Now, let's run this. It will take care of creating the data frame. You should be able to preview the data by saying orders.show. You can see the output here. Also, when it comes to the options, you should be able to use format and load combination like this. Earlier, we have passed all the options as keyword arguments to CSV directly. This time, we are actually passing it to load. Even this one will work in the same manner. So we should be able to pass the options either to CSV directly or to load. You can also look at the help on load. When it comes to load, you can see that you have to pass path as first argument, then format, then schema, then you have keyword arguments options. As part of these options, you should be able to pass all the options which you want to pass. This is how you should be able to use load along with format to actually create the data frame with schema. You should be able to preview the data of this new data frame called as orders. You can see the data as per the expectations. Now let's go to the details about spark.read.option. You can see that option takes two arguments. One is key, second one is value. Also keep in mind that option returns data frame reader. As option returns data frame reader, you should be able to invoke option again and again until you want to pass all the options. You can see an example here. In this case, I'm actually using option thrice. First time I'm actually passing separator. Second time I'm passing header as none. Third time I'm actually setting inferSchema as true. Now I should be able to run it. It will create the data frame by name orders. You should be able to review the results by using show in this manner. You can see the output. It is as per the expectations. You can also review the schema. The schema will be based upon the data type of each and every column. Order ID and order customer ID are of type integers. Order date and order status are of type strings. You can also use dtypes to actually get those details. So let me say orders.dtypes so that we can review the call names along with the data types. Dtypes is attribute and hence we don't have circular brackets at the end. Now you should be able to see the schema details using dtypes. Also we should be able to use options on top of data frame reader. If you look at the help on options, it takes varying keyword arguments. You see here, you should be able to pass all valid options with the appropriate key and values. However, if there are typos with respect to keys, they will be ignored. It will not throw any error. You should be able to go through the details with respect to all supported options by going through documentation. However, on top of these, there are also other options specific to file formats which are being used. Depending upon your understanding with respect to file format, you should be able to specify the options. In this case, this is how you should be able to use options. As part of options, you can actually say sep equal to pipe, header equal to none, inferSchema equal to true. All the three options will be used while creating the data frame. You can actually create the data frame by name orders. Then you should be able to preview the data as well. You can see the output. You can also use dtypes to actually get the data types of each and every column. Also, sometimes we might read the options from external files. Once we read the options from external files, they might come in the form of dict like this. In this case, options is of type dict. You can see here, it contains 3 key value pairs. The first one is nothing but sep with value pipe. The second one is nothing but header with value none. The third one is nothing but inferSchema with value true. Once you run this, it will actually take care of creating a dict by name options. If you want to pass these values to options, this is how you should be able to pass. This will actually convert dict into varying keyword arguments. It will actually translate the dict into this format. It will happen internally. Now, if you run this, even this one will exhibit the same behavior what we have seen previously. You can see that a data frame by name orders is created. You should be able to preview the data by using show. You can see the output as per the expectations. Also, when it comes to format and load, we should be able to use option or options the same way as we have seen with CSV directly. In this case, rest of the logic is same. I have replaced the CSV with these two. I have used format of CSV and path is passed using load. When it comes to options, I'm actually using options function. I'm actually converting dict to varying keyword arguments and I'm invoking options. Even this one will work in exact same manner as we have seen in the previous example. Now let me run this. It will take care of creating the data frame by name orders. You should be able to preview the results to confirm the data is as per the expectations. This is how you should be able to use options while reading data from files into Spark data frame. I have demonstrated using CSV as example. However, you should be able to use relevant options with any file format. It can be JSON, it can be Parquet, WARC, etc. That being said, it is very important for you to understand all different ways using which you should be able to pass the options. You can use option function or options function, or you should be able to leverage keyword arguments as well. The keyword arguments can be passed on direct APIs such as CSV as well as the APIs such as load along with format. As part of this lecture, let's go to the details about reading JSON files into Spark data frame. First, let's review the help on spark.read.json. You can see that it has several keyword arguments. Some of the keyword arguments are common between CSV, JSON, Parquet, etc. However, when it comes to other keyword arguments, they will be specific to the file format for which the API is built. That being said, you should be able to use this piece of code to actually read the data in this location. If the files in this location are in JSON format, then data frame will be created by name df using those files. Let's run this. In that location, we have JSON files. You can see that data frame is created. You can also use this approach to actually read the data from the same location into a data frame by name df. However, in this case, we are using format function with a JSON as argument along with the load. As part of the load, we are actually passing the path. Even this one will actually infer the schema by default. Let's run this. Let me say reload. I think it logged out. I have to log in once again. Once I log in, I should be able to run this. Now you can see that data frame df is created. When it comes to data frames, they have a function called as input files. You should be able to use it to actually get the details about the file names. Let me run this. You can see here. As of now, there is only one file in this location. The file is nothing but this one. Input files is the function which is available on top of Spark data frame. You should be able to even review the call names as well as data types using dtypes. You can see that the df data frame have 4 fields: order, customer ID, order date, order ID, and order status. You can also review the data types of each of these columns. Also, we should be able to preview the data using df.show. You can see the results as per the expectations. So when it comes to reading JSON files into the data frame, either we can use this approach or this approach. Either of the approaches will actually ensure the schema by inferring from the data. Now, there is a performance caveat with respect to inferring the schema from the data. We should be able to explicitly pass the schema even when we actually use APIs related to JSON. We will go through those details as part of the next lecture. When it comes to file formats such as JSON, Parquet, WARC, etc., even if you do not specify the schema will be inferred by default. However, when it comes to inferring the schema based on the data, there will be some performance impact. If the data volume is big, to accurately identify the schema, it has to go to the entire dataset. It will take its own sweet time to actually get the schema of the data. Then it has to take its own time to actually process the data as well. It means there might be performance impact if the data volume is large. If we infer the schema when we use APIs such as spark.read.json or spark.read.parquet or spark.read.warc while reading data from those respective file formats. You can actually run this. In this case, you can see that even though we haven't specified the schema, the column names are determined based on the data. Also, we should be able to run this to confirm the column names along with the data types. Even data types are inferred based on the data that is there as part of those columns. Instead of inferring the schema for performance reasons, in case if you wanted to explicitly specify the schema, you should be able to specify the schema either in the form of string object or in the form of struct type object. First, let's see an example using a string type object. In this case, schema is of type string. It have all the columns along with the data types. All of these are actually comma separated. This will take care of creating an object by name schema. It is of type string. It have valid schema in it. Once you have schema object in the form of string like this, you should be able to use schema on top of spark.read. You should be able to pass the schema. Then you should be able to invoke APIs such as JSON to read the JSON files from this location. Now, if you run this, Instead of going through the data to create the data frame, it will just use this schema. This time, if you don't have show, if you just have this piece of code, it will actually create the data frame much faster. Only when we perform the actions while processing the data, it will actually read the data. To infer the schema, it will not read the data. Instead, it will use the schema that is explicitly specified. Now, you should be able to pass the schema even using this approach. In this case, I'm actually using a schema keyword argument that is available as part of JSON. Even this one should work without any issues. You can see the output here. Also, before running this, let's review the schema that is inferred based on the data when we do not explicitly specify the schema. When it comes to order customer ID, it is of type begint. When it comes to order ID, it is of type begint. When it comes to order date, it is of type string. But we have data only from 1 to 68,883 with respect to order ID, 1 to 12,000 odd with respect to order customer ID. These values will fit as part of integer, and hence we might want to convert these to integers. Also, when it comes to order date, we might want to represent as timestamp. Those conversions can be taken care in this manner. As long as the data types are compatible, it will work without any issues. In this case, when we actually specify the schema, we have specified order ID and order customer ID as int type. When it comes to order date, it is specified as timestamp. Now, if you look at the output of D types, this time the data types are as per the schema that is defined while creating the data frame by using this piece of code. Now we should be able to specify the schema as a structure type object as well. If we want to use the structure type object, then first we have to import all these classes from types. Then we should be able to create a list of struct fields. This is nothing but a list of struct fields. Each struct field contain call name along with the data type. You can see here. Once we have list of struct fields, we should be able to invoke struct type constructor by passing that list. It will actually take care of creating an object of type struct type. Now let me run this. Let me check the type of schema. When it comes to type of schema now, it is of type struct type. You can see here. You can also pass struct type schema to schema or a keyword argument schema. In this case, I'm actually using schema function. Now we should be able to run this. It will work as per the expectations. You can also specify the schema in this manner. We should be able to remove this. Then we should be able to say schema equal to schema. Now we should be able to run this. You can see the output here. This is how we should be able to specify schema while reading JSON files into data frame. Make sure you are really comfortable with all the APIs so that you can actually face the certification exam with confidence. As part of this lecture, let's go to the side effects of inferring schema while creating Spark data frame. It is applicable irrespective of the file formats we are using. If inferSchema is used either by default or by explicitly specifying inferSchema as true, the entire data need to be read to infer the schema accurately while creating the data frame. If the data size is too big, then additional time will be spent to infer the schema. While inferring the schema, it will not be doing any other data processing. It will just go through the data. It will identify the column names, and also it will see what all rows doesn't have values. It will try to use null in place of those. Also, it has to go through the entire dataset to accurately determine the data type. When we explicitly specify the schema, data will not be read while creating the data frame. As we have seen, we should be able to explicitly specify the schema either by using a string type object or struct type. However, inferring schema will come handy to quickly understand the structure of the data as part of proof of concepts as well as design. If you want to come up with the design documents, if you want to analyze your data, you should be able to use inferSchema to complete the analysis a bit faster. Otherwise, you have to come up with a schema by going through the data and all. When it comes to files of type JSON, Parquet and ORC, schema will be inferred by default. You have to explicitly specify the schema to override that behavior. When we say inferring the schema, it will actually pick the call names and the data types using metadata that will be associated with these types of files. Whether you use JSON, Parquet or ORC as part of your files, the files will contain not only data but also the metadata. When it comes to CSV files, it is not default to infer the schema. You have to explicitly say inferSchema equal to true to infer the schema on CSV files. Once you enable inferSchema on CSV files, the data frame will be created with system generated column names. However, the data types of the columns will be based on the data in the files. If the files contain header, you should be able to use the combination of inferSchema equal to true and header equal to true. That way, you should be able to get call names from the header and data types by inferring the schema. If not, we need to explicitly pass the columns using toDF so that we should be able to leverage inferSchema to get the data types of the columns, and using toDF we will be able to get the column names. These are some of the side effects of inferring schema while creating Spark data frame. Make sure you keep these things in mind. There might be few questions around this as part of the certification exam. Even as part of the projects, it is very important for you to understand the overhead of inferSchema and also where it actually comes handy. As part of this lecture, let's go to the details about reading Parquet files into Spark data frame. First, let's look at the help on API called as Parquet that is available on top of data frame reader. When it comes to spark.read, it is nothing but of type data frame reader. It exposes a function called as Parquet. You can see that Parquet takes two arguments. One is paths, second one is options. When it comes to paths, it is of type varying argument. You should be able to specify multiple paths for paths. Also, you should be able to specify options related to Parquet in the form of keyword arguments. As options is varying keyword arguments, you should be able to pass as many keyword arguments as you want. That being said, now let me scroll down here. Let's actually read the data from this location. This location have Parquet files. First, let's validate whether this location have Parquet files or not. Then we'll actually take it further. I have copied the path. Then I'm actually adding a new cell after this. As we are using Databricks environment, we should be able to say dbutils.fs.ls. Then we should be able to specify the path. We can actually review this after running this cell. We need to make sure that username object is created which contain the login username. Once it is created, we should be able to use this piece of code to actually list the files in that location. It works when it comes to Databricks environment. You can see the output here. There is one file which is of type Parquet. You can see here. This is the name. This is the path of this file. You can see that Parquet files are by default compressed using Snappy. You can see the algorithm using which the Parquet files are compressed. Now, as these files are Parquet, we should be able to use spark.read.parquet and we should be able to specify the path like this. Now, the data frame will be created. As we have seen with JSON, even with respect to Parquet files, the schema will be inferred automatically based upon the data. It will actually go to the data to come up with the schema. You can actually use input files function on top of data frame to get the name of the files which are being used to create this data frame. You can see that there is only one file. It is nothing but this one. This is the fully qualified path of the file using which this data frame is created. You can also use df.dtypes to actually see the data types of each and every column. You can see the details here. When it comes to order customer ID and order ID, they are of type begint. When it comes to order date, it is of type string along with order status. Even order status is of type string. You can see here data type for order ID as well as order customer ID is inferred as begint. When it comes to data type of order date, it is inferred as string. Now you should be able to run this to preview the data. You can see the output here. It is as per the expectations. You can see all the four columns here. They're nothing but order customer ID, order date, order ID, and order status. Now you should be able to use spark.read.format with a load like this to read the data in Parquet files into the data frame. Even this approach will create a data frame by name df. Even this df will have the same four fields which we have seen earlier. Even using this df, we should be able to list the files that are used to create this data frame. You can also get the column names as well as data types by using this. You can also preview the data by running this. You should be able to see the output here. This is how you should be able to read Parquet files into Spark data frame using spark.read.parquet or by using spark.read.format with Parquet with load. As part of the load, we should be able to specify the path in which we have the Parquet files. That being said, in this case, the schema is inferred based on the data. Now let's understand how to explicitly specify the schema while reading the data in Parquet files into Spark data frame. As part of this lecture, let's review how to specify schema while reading Parquet files into data frame. In the previous lecture, we have gone through details about reading the data from Parquet files into data frame using default behavior. When it comes to the default behavior, it will actually infer the schema by going through the data. If the data size is big, then it will take some time to actually infer the schema. It can be counterproductive when we actually deploy the pipelines using inferring the schema as part of production. To address this, we should be able to explicitly specify the schema. Let's go to the details about how to explicitly specify the schema while reading Parquet files into data frame. It is same as what we have seen with respect to JSON earlier. Let's review. You should be able to understand without any issues. First, let's run this piece of code where we are actually creating an object by name username. This will contain the login username. The reason why we are actually creating this variable is because when it comes to Parquet files, they are under this location: /user, /login username, /retaildb parquet, then folders such as orders, order items, etc. Now, this is the spark.read.parquet by passing the path without any other options, which means implicitly it will infer the schema while creating the data frame. This will take care of creating the data frame. You should be able to review the data by using show on top of the data frame. Let's run this. We should be able to see the data here. You can see that column names are picked from the data which is there as part of the files. When it comes to Parquet file format, as part of files, we will not only have the data, but also the columns associated with the data. Also, as part of Parquet files, we represent numeric values and non-numeric values separately. For that reason, even data type of numeric values as well as non-numeric values will be inferred correctly. You should be able to review by running this. You can see that order customer ID and order ID are inferred as begint. When it comes to order date and order status, they are inferred as string. Now, we should be able to explicitly specify the schema using this approach. In this case, I am creating an object by name schema. As part of this string object, we have 4 columns along with data types. When it comes to order ID and order customer ID, they are specified as int. When it comes to order date, it is of type timestamp. When it comes to order status, it is of type string. Once you run this, it will actually create an object by name schema. This time, if you specify the schema explicitly like this, it will run faster because it need not go through the data to infer the schema. However, it will fail to convert order ID as well as order customer ID as int. You can see here. You see it is throwing error. It is saying Parquet column cannot be converted. Column order ID expected integer type found int64. When you use int like this, it will actually internally convert to int64. As it is of type int64, it is not working as expected. Now, if you change it to begint, begint is nothing but integer type when it comes to types in Spark, then it will work. However, this time it will fail on timestamp. Let's run this to create a schema. Now, let's run this to actually use that schema to create the data frame. You can see that it is failing. This time it is failing because order date is specified as timestamp here. However, when it comes to the error, it is not very obvious. It is not actually giving any details related to order date or timestamp. I don't know the actual reason, but it is not actually giving us the appropriate details. In this case, when it comes to defining the schema, I am specifying order date as a string. Now we should be able to run this to create an object of type string by name schema. It contains schema details. Now we should be able to explicitly specify the schema like this. Now data frame will be created. In this case, I am directly invoking show. You can see the output here. In this case, schema is passed as keyword argument and it is working as expected. However, if you want, you can also specify the schema like this. It will work without any issues. Let me copy this. Let me paste here. Now let me run this. You can see that it is working as expected. Now, as we have seen with the CSV as well as JSON, we should be able to pass a schema as a structure type object. If you want to build a structure type object, you need to first import all relevant classes from pyspark.sql.types. In this case, I have imported structure type, structure field, long type, string type. You can even use integer type. Let me use integer type in place of long type. Let me make sure long type is changed to integer type here as well. Now let me run this. It will take care of importing these 4 classes. Using these 4 classes, let me create an object of type structure type. You can see that I'm passing list of struct fields. I'm building struct fields using this information. We have call names along with the data types. Now this will take care of creating an object by name schema. It will be of type structure type. Using a structure type object, we should be able to create data frame. This will take care of creating the data frame by using the schema explicitly. I am also using show on top of it. Now we should be able to preview the data. However, it is failing. Again, it is actually complaining on order ID. It is saying expected integer type, but found int64. I have actually passed integer type only, but still it is failing. It means I have to use the long type only. I need to troubleshoot further to see why integer type is failing in this manner. Probably I might have to invoke integer type constructor with some arguments. I'm not 100% sure about it. For now, to move forward, let's change the data type to long type. Let's run this. Now let's copy this, paste here as well as here. Let's run this. Now let's run this. This time it should work. You can see the output here. Also, we should be able to pass the schema in this manner. You can see that it is working as expected. In this case, I do not have the show. That's why it is not previewing the data. I should be able to use orders.show to preview the data. You can see the data here. Once we create the data frame from Parquet Files, if you wanted to typecast, we should be able to typecast using appropriate functions. In this case, the order date is not converted to timestamp. It is actually converted to, when we try to convert it to timestamp, it is failing. It is because the representation of timestamp differs between Parquet Files and Spark data frames. That is the reason why it is not working as expected. With respect to JSON as well as CSV, it is working fine, but with respect to Parquet, it is not working as expected. In those scenarios, once we create the data frame, if the data types are not as per our expectations, we need to apply certain transformations to convert the data types. In this case, I'm actually converting order date to timestamp type by using this piece of code. When it comes to cast, while specifying the timestamp, the order date will be converted to timestamp as long as the dates are in this format. If you review the output here, it have date followed by time details up to seconds. Let me actually say truncate equal to false. That way we should be able to see the complete date. Now you see, this is how the data is as part of order date. It is a valid Spark timestamp format. Because it is a valid timestamp format, on top of order date, we should be able to use cast like this. Then we should be able to cast to timestamp. Once we cast to timestamp, the data type of order date will be changed to timestamp. You can actually run this and you should be able to review it. In this case, it is failing because I haven't imported call. First, let me import call. Then let me run this. Now you should be able to validate the data types. When it comes to order date, it is of type timestamp. You can also preview the data by using show on top of this logic. This is the data frame which actually contain order date as timestamp. On top of this data frame, I am actually invoking show. Now I should be able to see the output. You can see the details as expected. Also, we have changed the order date type to timestamp from string. This is how you should be able to explicitly specify the schema while reading Parquet files into data frame instead of inferring the schema. You need to keep an eye on data types of the columns. If the data types are not as per the expectations, you can consider typecasting in this manner. When it comes to reading data from files into data frames, it is very important for you to understand all different styles of APIs. You might get questions on any type. You should be in a position to answer those questions. Make sure you prepare well with respect to reading files into the data frames, especially using CSV, JSON as well as Parquet. Once you understand the nuances using these three file formats, you should be able to relate to other file formats and you should be able to explore by yourself. At least practice using CSV, JSON as well as Parquet. I don't anticipate any questions around ORC because ORC is not very popular. Spark actually promotes Parquet file format, and hence if there are any questions related to file formats, they will be around either CSV or JSON or Parquet. I'll be surprised if you get any questions using ORC. However, once you practice with CSV, JSON and Parquet, even with respect to ORC, you should be able to answer the questions without too many challenges.